Hello again from the workshop, OGS Mechanics and OGS Hybrid and EV. And today we've got another, hopefully interesting case. It's a Nissan LEAF ZE1. So basically this is the second generation as of 2017, equipped, well, obviously fully electric vehicle, equipped with a 62 kilowatts battery. There's not a problem with the range. Mileage is quite low. There's a problem with the very common warning light that comes on the dash on those leaves. It's about EV service warning light, restart inhibit after power off. Basically what this arrow codes on the dash says, the vehicle is still running. However, when the ignition is going to be turned off, the engine, the electrics won't be unable to restart. However, it can be restart after you clear the error codes, but obviously customer would not have a diagnostic tool to clear the error codes. It is a problem in the car, not with the range, but with the high voltage system. Now, let's get onto the into the workshop. But before we do so, we've checked this car, we've tested it, tried to experience the error code, and we couldn't. The car was actually driving very good, range was good. However, we've done some tests and we concluded there is an error on the vehicle, although it does not show. Probably with a more extensive road test, we would be able to experience the problem. But since we found something, I think it's the time to put it on the ramp and get the test underway and see exactly what is there and is not there always. Let's see. So the starting of the LEAF goes absolutely normal. Foot on the brake, ignition on. We can hear the relay clicking in. No error codes. We have 42% the battery and 103 miles range, which is very good. Being 62 kilowatts battery, this has quite long range, about 210. The book says about 240, but they don't really go that, but around 210. And according to what we have here on the 42%, 103, the range is there. However, still a problem. Let's see. So far, it looks okay, but it's not. Hello again. This is George from OGS Mechanics and OGS Mechanics Hybrid and EV. Here is the place where we fix cars, all type of cars, but mainly we are focusing on electric and hybrid vehicle. Stay close to see interesting repairs translated in videos. 350 volts, that's high voltage. The plan is that before we start stripping to check components, to have data read from the car. As already said, we have no error codes, but we want to see how good the battery is. And for this, we're going to use this tool to diagnose the battery. In here, we have just scanned all the control units on the high voltage system. There's an error code in the air conditioning, heating and air conditioning system, sun load sensor, but this is nothing to do with the high voltage. And here on the high voltage battery, we want to see the state of health and the difference between the battery, between the cells in the battery. So those are the stats that are very important to assess the battery condition. And here is the state of health, and it shows 95%. Considering the mileage that this car has, which is 67, it's very good. So we know the battery overall, it's in good condition, but what is triggering this EV warning light on? Also, it's well balanced. The difference between the cell, it's very low, 14 millivolts. Temperatures also looks good. So because we already run a diagnosis on it, we know there is an issue of isolation. Therefore, on those Nissan Leafs, The first point to start and check this isolation issue is at the back, between the rear seats and the front seats, where the service connector. We really have to check the high voltage battery, because most of the time that's where is an issue on those cars, which otherwise, to be honest, I think they're pretty good cars. So let's get there, strip it, and do the test to see whether the problem starts in the battery or if it's outside the battery. If we don't find anything there, it means it's going to be outside the battery, and then we have to check other components outside. Let's go. Well, Didi is going to make safe the car by disconnecting the 12-volt battery, correct, Didi?
Yes.
Okay. We are getting ready to access the service connector inside the car. Are you ready?
Yes, sir.
Let's go. Here is the point. Here's the point of interest, and here below this cover we're going to have high voltage light. Well, we're going to have the service connector of the high voltage battery. So we already have this one off. It should come up easy. And here is the service connector, which hopefully is going to come out. A bit of a fiddly job to take the lock off with the gloves on. Now it's out. So this service connector, what it does, it breaks in half the high voltage battery. However, there's still voltage here after this. Now, what we check in this next test that we are going to make, whether there is resistance between the high voltage circuit and the vehicle body. In theory, we should not have any. If we have, there is a problem. So with this tester, which we're going to connect one end to the vehicle ground, I have to try to get a good ground from let me see where I can do this, so we also have a good view afterwards. I don't need the gloves to do that. Okay, let me try it here. So let me show you how this works. In here we basically are measuring resistance but under load. Let me see if this works. No, we don't have good ground. We managed to connect the ground onto the vehicle body, basically on the battery's housing, and just to test the resistance. Now when we're pressing the load, we should have 0. So this means there is a connection. We should not have low resistance when we are checking the high voltage. And let's see what's happening here. So we basically have two sides where we're gonna check. Okay, we're gonna repeat the test. So this side of the high voltage battery, it is fine. Oh. So see, the second time this spiked to 0. Now there's a clear issue. So the point of the back of the service connector, there is resistance to the vehicle chassis. So it looks like there is a fault within the battery. Now, to fully understand this is from the battery, there's one more thing that we have to check, and this is to disconnect the high voltage cable that goes out of the battery. This is to make sure that the problem is precisely on the high voltage battery. For this, we have to get the car up in the air and disconnect the high voltage cable going out of the battery, and then redo the test. But it looks like the problem is going to be in the high voltage battery. Now the plan is to have the car up in the air and disconnect the high voltage battery. So basically isolate the battery, because we want to do again the test, and we want to make sure that the problem is within the battery because it could also be outside. We want to make sure we isolate exactly to the location. So it's set up correctly, did it? It is, yeah. The Nissan LEAF battery is one of the easiest battery to be removed after quite a few batteries that we have taken off on those electric or hybrid cars. So on the LEAF, the battery lies under the floor of the vehicle. So we need to take those under tray, plastic under trays. We need to access the high voltage connectors here and here, the orange one that we want to disconnect. Didi, let's get on. Oh, check it out. This is a lot of. This under tray holds a lot of debris that it gets over the time, and now with it off, we have quite full access. Not really. We still have another section, but we have access to the front section where we want to get. And here is the main connector that goes to the inverter, to the electric motor, and from the onboard charger inside the battery. And here is going to be the connector that goes to the heater. So what we want to do, we're going to take the connectors off, and we're going to do a resistance check to them, make sure that we have no resistance on them, and then by doing so, if there is no resistance in here, we have proved the problem is within the battery, and then we have to take it off. So let's do that. This is the main connector. To be taken out, not a very easy task. Very tough to be taken out. The second one should be hopefully easier. It's a bit also very hard to work with the gloves. And then, yeah, we can disconnect the battery. This is the connector that goes to the battery monitoring control units. But we want to carry out a test on those connectors. So actually, we're going to drop the car because we left the tester in the car. And with those disconnected, we're going to redo the isolation test on the battery, and then we're going to lift the car up to do the isolation test also on the connectors. Can you drop it down, Didi? We are back on the service connector of the high voltage battery, with the high voltage battery being now isolated of the rest of the high voltage components on the car. And if we have still resistance in here, let me see, which we do, it means we have a problem within the battery itself. So one of the cells or more are leaking to the vehicle chassis, which is not very good, of course. Now we're going to do the other test just to be certain there's no another current leak on the other high voltage cables, but everything so far points towards an internal fault in the battery itself. Again, same isolation test. Let's find a good ground, and we want to test those two cables to see. So let's see. First of all, prove that we have to turn it on and then prove that yes, if it's going down to 0, it's not okay. That's good. It's good. Perfect. So we proved there is no issue outside the battery. It is internal. So at this moment in time, we know the battery has to come down. So this is the next task, Nidhi. Ready for it?
Yes.
Oh. Having everything disconnected, now is the time to disconnect the high voltage battery from the chassis and drop it to our table. Didi, bring it here. Let's set it up. This is one of the easiest batteries to be taken off because it has only two cables, then the two high voltage, the control unit, and no cooling. Very, very easy. Didi, do you have the socket? Because I can think it's positioned correctly, no?
Yeah.
Yeah? Let's go. That would be the phone. How many volts? I could probably lift a bit more the. So we ready, yeah?
Yes.
Okay, so let's lower it. Simple as that. All okay there?
Yes, all good.
At the back?
At the back, yeah. Here at the back, here on the sides.
Yeah? And the battery is down. So this section was quite quick. Now, what we have to do from here is to take the battery in a different workshop, and we have to take the top cover off to get to the cells inside the battery and hopefully find the current leak of the cell. So are we ready in the other workshop? Okay, check, make sure we're ready, because we have to take it there. Let's put it all the way down, so it'll be easy to transport. With the battery now detached, is the time to put it in the workshop where we only work on batteries. Who's going to be the driver? Let's go. Is the brake on? No? What's the speed limit?
5.
It's not the smoothest road. Not sure how you're gonna put it. Yeah, turn it. Yeah. Sorry. So we have one Nissan LEAF battery, one Mercedes EQC batteries. Which one is gonna go out sooner? Oh, that'll be good. So in here, dismantling process. So first of all, you have to clean the edges under the bolts, and then we have to cut the silicon. So this top cap, obviously we have to undo the cap, this plate that seals the service plug on the battery, and then undo the top cover of the battery, and then cut the silicon and take it out. Didi, you know what I want to do? Let's do the isolation test once again, because you know sometimes when you take the battery, you move it around, and as we had it on the road here, there's a good chance might not have an isolation problem. And this is going to be a bit of a tricky situation, that when we take the cover off, we're not going to see the isolation where exactly it is, although we're going to have some indication. But let's see if the problem is still here, if it's still present. Just test it like that. Yeah, 0. Yeah, still here. The isolation problem is still there, which is good. Hopefully will still be there after we're going to take the cover off. Did he start cleaning everything? Yeah. On the Leaf, after we've cleaned the cover, what we're going to do, we're going to apply a spray to make the sealant soften, so we can cut it easily, because usually this silicone is quite thick and hard to be cut. With that substance, it's going to make it soft. It'll be easier to cut through, to take the cover off. This battery about 300 kilos, and an interesting fact, next there's an EQC battery. This one weighs about 300 kilos, we said, yeah? 300 kilos? 3. And this is 600. This gives about 240, because it's the 62 kilowatts, it's the bigger battery. This also gives about 210 miles. So 200 miles, 200 miles, 300, 600. Obviously the car is much bigger. So probably Nissan is half of the EQC. Yeah, it's the bigger car. Makes sense, isn't it? I think it would be, you want to hire?
Yes, a bit.
Yeah.
It will be easier to work with.
Yeah, because we have this facility.
I think.
Yeah? How many? You can move it higher or lower. So we have to leave this for about 20 minutes to action, and afterwards, like I said, it should be much easier to cut the sealant. Yeah, that's enough for now. This is going to be a seal, yeah, that's going to be easy, but the edges, take the bolts off, and then we have to use the cutter for that.
Ones are different.
Yeah, they're two
Especially
sizes.
the corner ones.
Yeah. Very interesting what they've done it this way, huh? Okie dokie. Now you have to take the cutter. Yeah. So look, another interesting design. So look how many bolts this battery has on one side. 3, 4, 5. And this is what, about 1.20 meters, 1.30 meters. Look how many bolts the Mercedes cover has in the meter. 2, 4, 6, 8, 12, 10, 12, 14, 16, 18, 20 plus. And they've done it with only 5. Different design. The cover now is detached. We cut, did discard the silicone, and we are ready to take the cover off and hopefully find the issue within this battery. So let's see. Wasn't too bad. Okay, let's put it somewhere against the wall. Have a picture. So that's how it looks, a 62 kilowatts battery for a Nissan LEAF. Totally different design than the 42 kilowatts. Now, let's do an isolation check and see if we can hear where it's leaking the current. So if you give me the tester, yeah. So this is some exercise as before, and now we have live voltage in here. Let's see if we can hear anything anywhere buzzing. Oh. Did you hear anything there?
I heard a click sound from her.
No. No. What we'll do now, we'll have to try to separate the modules to really locate where is the cell with the leak. Now, usually is the row here at the back, and to do that, the easiest way, so let's first of all take the BMS, disconnect the BMS, so we make sure we don't have an issue. Very hard to hold. Okay. So let's run again the test, because sometimes it could be that the reading is incorrect due to the sensors. No, this is still there. Okay, so we wanna separate the banks. So try to locate which bank is causing the leak. More inclined to say this is the bank at the back, because usually this is the one that gets very hot. Let's see how we are going to do this. So what are we going to do? We're going to disconnect the bus bars at the very end of the pack. And if we are correct, after disconnecting the two bus bars, this and the other one, we are still going to have resistance here. Then we're going to locate the leak being in the battery in the pack at the back. So by doing this small exercise, we kind of isolate so basically this is a separate bank, and let's see whether we still have resistance. And we still do. Now we know for certain the issue is within this bank. We're going to go further now. And what we're going to do now, Didi? Yes, we're going to disconnect the bus bars between the packs. Can we bring me the multimeter? I want to see how much this bank has now. So what voltage are we working? Because we basically broken the battery in smaller battery. So if you hold this on the voltage, let me see what we have. What's the reading there? So we have, oh, you know why we have this much? Because we have actually service connector which interrupts. So if we measure like that, no, with the other one. So we have 66 volts here, yeah, and then we should have another 66 in here or more. Another 66. So together 112. 132. 132 on this bank, which now is separated in two, and then if we separate it in two, so we know which half it is, isn't it? We know already because it's the bank. Hold on. So we said this is the bank. Yeah, 66. So we have resistance in the one in front. Am I correct? Which one do we have resistance on? Make sense, Didi? What we're doing here?
Yes, yes, still trying to understand.
Okay, so in here we have resistance. In here, where's the other bus bar? Hold on. No, hold on. The bus bar is here. Sorry. So let's see. Theory. Here we should have no. It's actually the other side. Okay, so this half, from this half. So we know it's going to be one of those elements. This part is good. Okay. Now, let's try to understand how those elements will come out. We'll need to separate the bus bars all. It's a slightly different design than the one on the 40 kilowatts. And I'm just trying to make a plan of action. So at least we know it's from here onwards, and what we can do, we can remove the bus bar to really pinpoint the block that is going to have the problem. And you know what, I'll rather do that now, because it could be that if we leave it, tomorrow might end up with no resistance, and then it will be very hard to understand where exactly the problem is. So let's do this exercise. Let's have them all disconnected. Now, with the bus bar removed, we're going to check which element it has resistance. So it's actually the very end element in here is the one with the problem. Now, to take it out, I'm just trying to understand. So if we take this bracket apart, okay. So you just have to remove the very end of it.
This is a single one.
Yeah, this is a single bracket, but once we take this one off, you take the control unit, take this bracket off, we'll be able to pull these arms. Okay, well, let me just one more time. Yeah, it's certain we locate the problem on this. Let me take this other bus bar off. Don't want to take the bus bar completely off. Okay. Give me also a 12. We're going to take the control unit off. Take the control unit. Quite long bolts that are holding in place each pack. So we need to do this bracket, and then we should be able to pull out the pack that is causing our issue and really narrow it down. What I find a bit different here is the fact that the elements, they don't look very swollen, where at least so far, when I released the bolt, they did not expand too much. Okay, hold this. Before we'll attempt to take it out, let's do another isolation test and check this out. And I'll tell you exactly what happened. So if we check it again now, have a look. There's no longer resistance on this pack. Do you know why? Because the pack was compressed, and when it was compressed, inside the battery has some sacks with the electrolytes and all the chemical of the battery, and that was leaking to the body of the battery. Now, when it expanded, it was ever so slightly in the connection where it, when it's expanded, it no longer leaks to the ground. But if we were to undo the battery and do the test, we would have been in a big problem, because now we could not tell where exactly is the problem, but we know is on this pack. We're going to take it out and try to have a good understanding, but most likely we might end up replacing the whole lot or section of it. We have to see exactly, because I have not taken one apart of the 62 kilowatts before. So let's see how we're gonna take this one out. This is heavy thing. Okay. So this is how packs look like over 62 kilowatt battery. Can I have the multimeter, please? So can you set it up on the voltage? So each pack, it has 33 volts and is a lithium ion battery. And then if you're considering that each cell, it has about 3.5, for instance, approximately, So we might have about 9 or 10 cells inside. If we have 33, yeah, probably we're going to have about either 9 or 10 modules, but they come together. I'm going to do some checks. They're going to come together. So it looks like to fix the problem that we had is to replace this whole block. So I think it's the time that we're going to go online, do some checks, see exactly where we can find a pack. You know, a nice story about this car and the repair. The car went to the dealership and it sat there for 2 weeks in order to make a plan of action. If you think about it, you look back, yeah, well, it's not very complicated, it's not very easy, but don't understand why the repair could not have carried on. Anyway, we have to see how difficult it's going to be for us to locate a part. So we got some homework to do before we get back to put the battery together. We've got mail. Well, not mail, we've got delivery. So we've got a replacement pack. Sure, hopefully should be balanced to the voltage of the others. Do you know what it was?
Yes, so the rest of the ones, it was 33.1718, and this one is 33.20.
That's perfect. So that's close. Can you measure it? Obviously, we'll do another check over when we are. Hold on. Yeah. 1.7. So that's exactly what we have there.
Yes.
Perfect. It's very important to be balanced. So let's take the cover off. And proceed. We're gonna can put it here for now. There'll be a lot of cleaning on the old sealant. Yeah. Don't really fancy the covers that they are sealed on with silicone. Yeah, some of the batches they are sealed on with the gasket. Such an easy job to work on them. Okay, so which one was the pack? That was the pack that we have to take it out. And install the replacement and then everything back. So we're gonna do a balance check. Let's see. I'll need your help here. Okay, so if you take this bar out, that's fine. I think we're ready. Are we? Oh, this is a heavy thing, isn't it? Yeah, put it there for now. Perfect. And let's have. Let's have it in, yeah?
Yeah.
Definitely not the easiest pack. That's gonna be the bus bar, yeah? So this is gonna be the link between the batteries, correct?
Yes.
In the same order of dismantling, everything has to go back now. And until Didi brings the gun, let's do another measurement on the other cells, just to confirm. So what we have here, 33.16. That's good. Perfect. Perfect. So well balanced. This is very important. So we don't have big differences between the cells. So the plan is to secure all the packs in place, and then we'll start connecting the bus bars, and then the battery control unit. Here where the battery control unit goes. I think we got them all done up, and now we're gonna torque them up. 28, yes. Done. Perfect. Let's double check. So the cells are secured now. We need to run the wiring and the bus bars. Okay, so we have everything connected here. Now my plan, before we put the cover on, is to connect the tool and see if we can read the stats about the battery. But there's one other important thing that we have to do before we do that.
Insulation.
Exactly. So let's run another insulation test to make sure the pack that we receive, it is actually in good condition and we have no surprises. Actually, we're gonna lift again the cover. Oh no, but we could easily check it. So we have to make sure that the pack that we have received is in good condition. We have been told it is in good condition, but we have to check. This is our module. Initially, it had resistance, you see? It's interesting. Why that? Okay, so we have okay, I think I kind of get it. Tell me if you get it. Disconnect the plugs from the control unit. Put it back. Hold on, put it back. Go on. No, we don't have it. Take them off. Off, all of them. See? Put the other one back. Bingo. You see? Do you know what that is? There's a bit of resistance created through the sensors, through the cell sensors. So we are happy with the resistance in the high voltage battery. Can we get some reading out of it? Yeah, so I think we finished with the high voltage system. We already have this set up. So basically what we are doing, we are connecting to that module over there, which is the battery control unit, through the connector here. So It's a wiring diagram where we connect to power supply and communication network is correctly connected. We should get communication with that control unit. So in here, we're gonna see stats about what is going on in this battery, and we wanna see that before we put it on the car because it is a bit of work. If it's anything, we wanna know now. We know the isolation test has passed, and we want to know what is reading this module. This is the module that controls the functionality of all this. And more important, the balance of all the cells, obviously because we've replaced one of them. And in here, we're gonna see those stats. Let's see how they look like. And it looks very good actually. So we've got 15, 14 millivolts difference between all the modules, which is absolutely fine. So we are happy with that. Our module that we replaced, we're gonna locate it now. So basically, if we hold the battery like this, our one is the module 10, is the one over here. And let's have a look. Module 10, 7 millivolts, so quite happy with the stats on it. But the battery overall is well balanced and its state of health is very good. So it was just a pack that has failed. But having all those stats, we are happy to get the battery packed up. Now it's down to Didi to do the tedious work of cleaning all the silicone on the body of the battery, on the cover. Then we have to apply the silicone and seal it back and back in the car. My work is done here for now. I will leave it to you. Are you ready, Didi? So clean all the silicones and then laid out quite a thick layer of silicone both on the cover and the body of the battery. And we're ready to put it on. 66, yeah. Yeah. Center, 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 center. Ooh. Like a charm. So with a thick layer of silicone, both on the cover and the body, we should achieve the perfect seal because it's very, very important. No moisture should ever go into the battery. Obviously, high voltage, but water and electrics, they don't go well together anyways. We're ready to have this battery sealed. And back on. Battery, it's all together, ready to go back on the car. And this little component, it's only going to be installed once all the work has been completed on the car and the battery is fully connected. Lal, yeah. Give us a push, my friend. Let's hope Didi's gonna open the gate for us. We've got a present for you. Christmas comes early. Yes. The high voltage. And the battery. So we're done here with the connectors. Need to secure the bracket on the high voltage cable. All the bolts on the battery, and we're pretty much ready to have the ignition on, but we're gonna put the under trays anyway. We're gonna fit everything because it's not much to test underneath. No cooling, nothing really special. So we're gonna finish everything underneath. We're gonna put the under trays and get the Nissan out in a drive test. Obviously, we know the resistance is there. We couldn't experience the problem before we stripped the car, before we started to investigate, but we noticed the resistance while we're checking the battery, and we know that's not there anymore. We're gonna do an extensive road test, and just to be safe, we're gonna do another isolation test in the high voltage plug, just to prove the resistance test is passed. And if all good, the car will be ready to go to its owner because he really wants to have it back. I think we're just about ready. Are we? Yes. Where is the safety plug? Because the last touch has to be done. So you have to put a safety glove, the service plug, 12 volts, battery afterwards, and we're ready to go. Yes. Nearly there. So we're gonna get this Nissan running. So the most important part on the safety side is now connected. Didi? We now going to put the cover back on. No, we're not going to put the cover because we're going to do an isolation test after the drive test. So we need to connect. Yeah. So hopefully we're going to have ready coming on. Yes? No? Yes? Maybe?
No, yes.
Let's see. Can I drop the car fully, yeah?
Yes.
So, okay, let's scan the car first of all. Do we have any warnings? No? No, we shouldn't. Okay, so let's see, in here might have something because we had the battery disconnected. Yeah, so none of them are current. The only one that is current is sound load sensor, but this is for the air conditioning system, which might be important if the battery would be AC cooled. Is not the case. Nevertheless, there is an error, but not related with the functionality of the high voltage system. And I think we are ready to test. We should have ready coming on with the foot on the brake. We had the Leaf in an extensive drive test. We had the battery fully charged, and with a fully charged battery, it shows an autonomy of 250 miles. Again, 62 kilowatt battery, so you can see that. Now is the time to put do the final check, so do another isolation test. No error whatsoever on the driving, but so it was the case before. So we want to make sure that it passes again the isolation test. Then we have to install the cover back and then have to go through the final recap and the cost. Let's get in the workshop. Now, to conclude the work, we're gonna do one more time the isolation test in the high voltage battery. Have we disconnected all? We did. So Didi made everything safe for us. Let's get to the back of the car. So right, so the access here. Didi, if you can hold me the light a little bit. I'm just trying to pull the connector out. Okay, so the battery safety connector is out, service connector is out. Let's try to get a good ground. Well, obviously we're looking for a high resistance. A low resistance is not going to be good. Ready to test. Brilliant. Goes down. Perfect. Yeah. Isolation test passed. The battery is in good condition. If we're gonna put the connector back, I'll leave the rest to Didi to put the cover on. To put the cover until we cover the rest on this repair. So with the road test completed, isolation test passed again, we are getting ready to finalize the job on this Nissan LEAF that had the range but had the narrow code, and he had the message of no start after the ignition being turned off. Quite common, seen on other LEAFs. And then for that, we've done a check on it. We concluded the problem comes from the high voltage battery. More precisely, one of the pack unit was leaking. When we got it undone, the leak was not there anymore, so only when the pack is compressed. Anyway, we've got another unit, we've replaced it, and the car is ready. But, where is it? Where is it? Here. What was the cost on this Nissan LEAF to be back on the road? We didn't have many parts. We had only the high voltage, the battery pack. Now, the problem is, every now and then there are cheaper parts available, but at this moment in time when we're trying to locate a pack for a 62 kilowatts battery, there were literally none available, so we had to make quite a few phone calls before we found one. Is a new used one, but it is in good condition and the battery is balanced. Anyway, the cost of this pack was a whopping 1,200 plus VAT, so quite expensive. What was the cost of this work? We summed everything up, so from initial check to strip the battery, further checks, then get a cell, balance it, install it on the car, install it on the battery, test it, install it back on the car, drive testing the car. So all this, so investigation and replacing the pack, it was 1,500 plus VAT. So we're gonna have a total of 2,700 plus VAT. And now this Nissan LEAF is ready to go back on the road, autonomy of about just over 200 miles, so the car is ready. So if you like this video, don't forget to subscribe, click the notification button, because we have weekly videos with real repairs from the workshop, real situation. Also leave me a comment if you liked it, and stay close, because I'll see you soon with another video.